Introduzco yo. Buenas tardes a todos y todas. Bienvenidos a la octava sesión de la Mesa de la Frontera Tecnológica en el marco de la iniciativa Desafíos Forestal para un Chile Sustentable de la Comisión Desafíos del Futuro del Senado. La Mesa de Tecnología, como ya hemos comentado antes, parte de una de las 5 mesas de esta iniciativa y tiene como finalidad detectar y analizar las brechas tecnológicas existentes en el sector forestal y maderero. A partir de esto, buscamos determinar propuestas e iniciativas que nos ayuden como país a avanzar hacia la sustentabilidad y obviamente la sustentabilidad en torno al uso de nuestros bosques y la madera. La temática que abordamos la semana pasada y que continuamos hoy en día tiene que ver con los escalones productivos, a los escalones finales de la cadena productiva forestal, relacionados con innovación en manufactura, digitalización y construcción en productos de componentes para la construcción o objetos en madera. Tenemos hoy día 3 invitados. Partiremos con Francisco Quitral, él es arquitecto de la Universidad Federico Santa María, es investigador en el área de robótica. Después continuamos con Matthew Barnett Holland and Oliver de CSK Arquitectos y UCL respectivamente. Y finalizamos con Tom Swillans, que es investigador postdoctoral de CITA en Dinamarca. Dejo como primer expositor a Francisco, pero antes de eso les voy a explicar un poco la metodología. Las exposiciones van a ser consecutivas y luego pasaremos a una ronda de preguntas. Y tenemos el link del Jamboard en el chat para que vayan los asistentes y los invitados puedan ayudarnos a recopilar información o comentarios ahí. Tom, Oliver, is a link in the chat of the meeting. That is a Jamboard platform, like a screen. You are also invited to join and type some comments, even if it's in English, that's all right. Ideas of things that you can, if you have something to share, that we can use it after to develop the document that need to develop for the Senate. So, todos están invitados a rellenar eso. Bueno, Francisco, puedes partir cuando gustes, compartiendo tu pantalla.
¿Se escucha bien, cierto?
Sí.
Ya, voy. Ahí está pantalla completa, ¿cierto? Okay.
Sí, te vemos. Gracias, Francisco.
Ya. Muchas gracias. Buenas tardes a todas y todos. Es un honor para mí estar presentando en esta Comisión de Tecnología para el Senado de la República de Chile. Mi nombre es Francisco Javier Quitral Zapata, soy arquitecto, profesor e investigador en la Universidad Técnica Federico Santa María y también doctorando en de arquitectura en la Universidad del Biobío. La presentación que haré va a consistir básicamente en robots en arquitectura, desde la formación pasando a la investigación y desarrollo en Chile. Como primer contexto, ¿no es cierto?, muestro este mapa internacional de los robots en la industria creativa, desarrollado por la Asociación Internacional de Robots en Arquitectura, de la cual somos miembros desde el año 2013. Y posterior a eso se ve en la imagen inferior izquierda, una actualización de este mapa también, en donde aparecen el Design Land de la UAI, de la Universidad Adolfo Ibáñez, desde el 2015, y en el año 2019 también aparecen por acá abajo, ¿no es cierto?, en el sur de Chile, la Universidad del Biobío y la Universidad Autónoma. Nosotros pertenecemos a esta Asociación Internacional de Robots, ¿no es cierto?, desde el año 2013, formamos parte con el Centro Integrado de Manufactura y Automatización, que está en Casa Central, en Valparaíso, ¿no es cierto?, en la Universidad Técnica. Y bueno, a partir de ahí que hemos estado desarrollando en el área de profundización del Departamento de Arquitectura, en el área de profundización en robots en arquitectura, ¿no es cierto?, que también tomamos prestado el nombre de la asociación, con el debido permiso, claro, en el cual nosotros actualizamos métodos, herramientas de la disciplina, ¿no es cierto?, educando, investigando, desarrollando e innovando para el avance de la arquitectura hacia la industria 4.0. Nuestra línea de investigación principal es la carpintería de armar robotizada, la cual básicamente intenta recuperar un método ancestral de construcción sustentable, un sistema constructivo basado en la prefabricación de piezas lineales de madera que se encajan y se traban. También aprovecho dejar abajo los enlaces, ¿no es cierto?, donde se pueden visitar el área propiamente tal y también un canal de Vimeo donde hemos publicado nuestro trabajo en video. Desde el año 2015 que estamos formando arquitectos en estudiantes de arquitectura de segundo y tercer año, aplicando conocimientos de rinoceros, ¿no es cierto?, de este modelador tridimensional muy popular en las carreras de diseño y arquitectura, implementando también la programación visual en Grasshopper, ¿no es cierto?, este ambiente de programación inserto dentro del modelador 3D, y además también trabajando con el control paramétrico de robots KUKA con KUKA PRC, que cabe el crédito, ¿no es cierto?, a Johannes Braumann, el arquitecto austriaco, que el desarrollador líder de esta aplicación, que permite, ¿no es cierto?, controlar un robot manipulador desde este entorno gráfico. Tenemos aproximadamente un promedio anual de 50 estudiantes que pasan por esta asignatura, y desde el próximo año esto se duplicará porque, por la apertura de nuestra carrera en el campus San Joaquín en Santiago. Con esas cifras, ¿no es cierto?, podemos aproximar que este año, a la fecha, ya hemos formado 300 arquitectas y arquitectos con competencias para la industria 4.0. Básicamente con los resultados de aprendizaje que permite automatizar tareas de diseño, combinando diseño asistido por algoritmos y programación visual de robots. Destacamos esta formación de profesionales que saben, que lo denominamos que saben diseñar y programar, y creemos que es un modelo único en Chile que incluso podemos evidenciar de su exportación a nivel nacional e internacional. Por ejemplo, desde el 2018, en laboratorios de Ingeniería Civil Industrial, Mecánica y Diseño de Productos en la universidad, también hemos correferenciado o guiado a algunos memoristas de Ingeniería Civil Electrónica y Mecánica, la UTFCM, utilizando estas herramientas. También tenemos experiencias internacionales en la Universidad Nacional de Colombia y en la Universidad Pontificia Bolivariana, en la sede de Medellín, donde también nos ha tocado impartir workshops y hacer simbiosis, ¿no es cierto?, con estas instituciones para exportar el modelo. Esta metodología de trabajo, ¿no es cierto?, estas herramientas que nosotros enseñamos en las asignaturas de métodos computacionales, o métodos, como lo denominan nuestros estudiantes, que a todo esto son asignaturas de la parte formativa de nuestra malla curricular. También se ha extrapolado a los talleres de diseño de arquitectura, los talleres avanzados que nosotros denominamos, que son donde trabajan estudiantes de cuarto y quinto año de la carrera. En este caso en particular lo que estoy mostrando es el taller avanzado que participó en el concurso de arquitectura de la Corporación de la Madera del año 2018, diseñando un edificio multiprograma en mediana altura, y también como un intento, mostrando, ¿no es cierto?, también como un intento pionero en Sudamérica, ¿no es cierto?, introduciendo los robots industriales en la creación arquitectónica y también en los talleres de arquitectura con estudiantes. También, obviamente, utilizando técnicas mixtas, ¿no es cierto?, con herramientas de corte y herramientas manuales también. Esos resultados, ¿no es cierto?, o ese trabajo derivó en estas maquetas y prototipos, ¿no es cierto?, de los detalles de uniones, que es particular lo que estoy mostrando. No estoy mostrando los proyectos de arquitectura, sino estas maquetas y prototipos que son las que se realizaron con esta metodología, ¿no es cierto?, de programación visual, y mecanizado en el taller de arquitectura, donde entregamos, estos fueron las maquetas a escala, ¿no es cierto?, de los proyectos de los estudiantes, donde se detallan los encuentros, los ensambles entre piezas, algunos con mayor o menor complejidad, pero también, insisto, mezclando técnicas, no todo fue mecanizado por robot. Desafortunadamente no ganamos nada, pero nos quedan estos hermosos resultados. Este esfuerzo, esta metodología, ¿no es cierto?, en la formación también ha llegado a los trabajos de título, pasando por el ciclo formativo, ¿no es cierto?, el ciclo avanzado en los talleres de diseño y finalmente en el quinto y sexto año también de la carrera, donde los estudiantes desarrollan un trabajo de título. En este caso voy a destacar 3 trabajos de arquitectos, el arquitecto Diego Poblete, ¿no es cierto?, donde realizó un prototipo de puente peatonal de madera ensamblada con uniones carpinteras, mecanizadas con un robot industrial. Aquí nuevamente estas son imágenes que el mismo estudiante tomó durante su proceso de desarrollo de este trabajo de título, ¿no es cierto? Y nuevamente aparece la herramienta de programación visual. Este trabajo, debo reconocer que ha asistido también en el laboratorio para el mecanizado de las uniones, y finalmente el estudiante muestra su prototipo funcional como proyecto de título. Un segundo trabajo de título del año 2018 del arquitecto Cristian Huentelicán, un prototipo de vivienda en madera, también ensamblada con uniones carpinteras mecanizadas por un robot industrial. Este trabajo se presentó, como se muestra en la imagen de la derecha, durante la Semana de la Madera del año 2017. Nosotros constantemente hemos sido invitados y en las primeras instancias fuimos partícipes, ¿no es cierto?, en las exposiciones de la Semana de la Madera. Un último trabajo más reciente de la arquitecta Michelle Ramírez durante el año 2019, donde desarrolló un sistema estructural basado en la carpintería armada robotizada, pero para, en este caso, una edificación en madera de mediana altura. Este trabajo está inserto, ¿no es cierto?, dentro de una competencia internacional del Solar Decathlon USA 2020, donde la universidad como equipo, ¿no es cierto?, como team, participó a nivel interdisciplinario. Y finalmente lo que se ve a la derecha, ¿no es cierto?, es el resultado de todo este proceso en que Michelle ya diseñó el modelo estructural, pero posteriormente esto se llevó a un mecanizado, que debemos dar crédito aquí al aserradero Boipir, que tuvimos una colaboración ahí para la manufactura de las vigas laminadas y el mecanizado, y finalmente este prototipo se fabricó, ¿no es cierto?, y participó de esta competencia internacional, y esta construcción finalmente es una vivienda que se instaló en el Cerro Rocuant, en Valparaíso, ¿no es cierto?, y es parte del programa de reconstrucción a partir del incendio de la Navidad del 2019 en Valparaíso también. Pasando ahora a la investigación y desarrollo, durante el año 2015, cuando yo me integré como profesor también, los colegas se habían adjudicado, ¿no es cierto?, un proyecto FONDEF, también en la misma línea, ¿no es cierto?, de la reproducción robotizada. En este caso, el título en particular es la reproducción robotizada de elementos estructurales y ornamentales de geometría compleja para la restauración y rehabilitación del patrimonio arquitectónico. La verdad que el proyecto no alcanzó su madurez en la parte ornamental de la geometría, pero sí en la reproducción robotizada de los elementos estructurales y de las uniones carpinteras del patrimonio histórico de Valparaíso. Un resultado de este proyecto de investigación también es el libro de los colegas González y Maino, Uniones Carpinteras de Valparaíso, como un producto de la investigación, y también como un intento por relevar o poner en valor el oficio de la carpintería de armar tradicional. Y claramente el patrimonio arquitectónico también de las uniones carpinteras. Finalmente, el proyecto de investigación que tenemos actualmente en curso también es otro proyecto FONDEF que inició el año 2020 y finaliza el año 2022. Que el ejemplo que estoy mostrando aquí básicamente es uno de los experimentos que estamos desarrollando actualmente en la universidad, utilizar Computer Vision para la referencia geométrica de una pieza de trabajo para la carpintería de armar, con la intención, ¿no es cierto?, de ejecutar un trabajo colaborativo, humano-robot. Pero siempre también, ¿no es cierto?, en la línea que ya he mencionado de la carpintería de armar robotizada. El proyecto en particular se va a enfocar en soluciones habitacionales flexibles, también en madera para los procesos de reconstrucción del Serviu y del mismo. Finalmente quiero hacer una breve reseña a mi proyecto de tesis doctoral en la Universidad del Biobío, donde aquí intento resumir los años de investigación, ¿no es cierto?, y en particular mi área de interés en el estudio, ¿no es cierto?, en esta secuencia que ya he mencionado, ¿no es cierto?, en los software de Rhinoceros, Grasshopper y KukaPRC para la programación offline de trayectorias, pero en particular en mi proyecto de tesis doctoral yo me quiero enfocar en la verificación empírica o en cómo somos capaces de integrar las tolerancias, ¿no es cierto?, o las deformaciones naturales del material de la madera y cómo estas se pueden integrar en el proceso de diseño o en la programación o en alguna etapa previa a la fabricación. Aquí debo dar reconocimiento a la beca de doctorado nacional del año académico 2020 que financia esta investigación y al programa también de doctorado en arquitectura y urbanismo de la Universidad del Biobío. Para ir cerrando, mostrar lo que se nos viene en investigación y desarrollo en la universidad y en el departamento. Ya en octubre, probablemente de este año, si todo sale bien, vamos a tener nuestro laboratorio de construcción y manufactura robotizada en el campus Santiago, en San Joaquín. Y todo esto gracias al equipo del área Robots en Arquitectura, Luis Felipe González, el encargado, Francisco Quitral, quien les habla, y Eduardo Valenzuela, otro colaborador del grupo. Ahí dejo mi contacto y muchas gracias por su atención.
Gracias, Francisco.
Justo en el tiempo parece.
Justo en el tiempo. Bueno, Francisco, el equipo de la Federico Santa María fueron los pioneros básicamente en Chile de combinar la robótica en arquitectura directamente, no solamente en construcción, sino directamente en arquitectura. Después lo seguimos varios pasos después nosotros. Vamos a continuar con Matthew o Oliver, no sé quién va a exponer. If you can share your screen and start.
Yeah, we'll start. I think I'm going to give this talk and Matthew might chip in. Right, let's see if I can get this screen sharing to work. Okay, hold on, let's try again. You've probably got the wrong screen, yeah?
I can just introduce you while you're fixing that.
If you don't mind, yeah, let's
just
right. See. Okay, I think this is going to work okay this time.
Bueno, Matthew y Oliver son arquitectos actualmente trabajando en el Reino Unido.
Okay.
Su trabajo de investigación involucra el diseño y la fabricación de vivienda con biomateriales, de relación bosque-bosque en el fondo, del bosque a la vivienda. Y han sido premiados internacionalmente por sus diseños y por la innovación en los procesos y el uso del material. That, you can start. Thank you.
Great. Can you see the correct screen okay, yeah, with the start screen?
Yeah.
Right, okay, good. Great, thank you. Can I speak at a normal speed or should I speak a bit more slowly or?
I think it's all right.
Normal speed, fine, okay.
It's fine.
Great. Okay, so we'll make a start. Okay, yeah. So quite a number of people were involved in this project. And I'm going to be speaking about it today. I'm Oliver Wilton from Bartlett School of Architecture, and Matthew Barnett Howland was the lead on the house. He's here too. And Mike Arnett, who's also here in the background, was the research assistant for the robotics bit and made a big contribution to that too. So we've got quite a good representation tonight, which is great. Okay, so let's get started. Okay, so this is quite a complicated project. The talk today focuses mainly on the use of digital technology, which we understand is the sort of focus for this session. So the aims. Let me just see if I can move that out of the way. So the aims for this specific work was to develop a robotic milling method that could shape cork billets, which you can see on the left, into the cork building blocks you can see on the right. And the idea was that this could contribute to the development of the cork construction kit, which is a relatively simple new form of construction, a bit like giant plant-based Lego. This was developed with a number of partners who were mentioned later under a broader research project and was then applied in Cork House. Here's the context for this, which is very relevant here. So cork's the outer bark of the cork oak tree, stripped around once a decade in a process that doesn't harm the tree. And using cork helps to support these quite biodiverse agroforestry traditions that you find around the Mediterranean basin. The material we used in this project is pure expanded cork agglomerate. It's supplied by project partner Amarim. And here, waste cork from forestry and other industries is granulated and then steam cooked in autoclaves, which you can see happening on the slide. The cork expands, and the natural resin in the cork, called suberin, melts and then rebonds to form blocks of pure cork with no added ingredients. And that's what really attracted us to this, a kind of industrial plant-based product without petrochemical binders. It was invented in 1891. It's not a new material. And it's been extensively used in construction for over 100 years, ranging from insulation, as you can see on the left here, in a Spanish slaughterhouse, to self-supporting partitions in the center in a large American cold store, to the first use as external cladding by architects Caesar and Suter 20 years ago at the Hanover Expo. Expanded cork has a unique combination of properties, and the basic hypothesis for the broader project was that we could replace current typically complex layered forms of construction represented on the left with a solid cork building envelope represented on the right that would still fully meet all current building performance requirements. And to complement the material simplicity, we intended to use a simple building technique. Our initial point of reference was historic forms of dry stone construction, such as this French borry, which are built by simply placing one block on top of another. And they come with associated typologies that reflect their character as simple compression structures, using walls and corbelled roofs to give enclosure. So we got started. Initial prototypes were fabricated using traditional machine tools. And we soon moved on to focusing on pure cork structures using tongue and groove geometries. You can see here to give a simple interlocking fit that requires no glue or mortar. Soon we discovered that while there's a simplicity in asking one material to perform all the functions of a building envelope, the shape of the blocks themselves can become rather complicated, especially in the corbelled roof, which you can see on the right here. And this is because of what we were asking the blocks to do. So as well as providing structure and needing an interlock for that, we also wanted them to keep the rain out and provide air tightness along with thermal insulation. Now, at this point, analog fabrication was proving to be quite challenging due to the time taken to shape each block. And it was also difficult to achieve sufficiently low tolerances in order to give a snug block-to-block interference fit. And the simple prototype cabin that we intended to build had around 200 blocks, and that included 10 unique types of varying length, giving 28 different block geometries in total. So we started to consider using robotic milling with the aim of being able to fabricate blocks sufficiently accurately and relatively quickly. And we were lucky to be based at the Bartlett with people, with colleagues from BMade and people like Mike Arnott around who knew what they were doing on this. So the workflow we used at this stage was that we used SolidWorks for modeling. You can see on the left, and the individual blocks were then exported to PowerMill Robot in the middle to generate the G code for milling. And that worked to an extent. And we also put in use Rhino with the bespoke Grasshopper script, which you can see on the right. And this is the work that Mike Arnott was very heavily involved in. So, and a cooker industrial robot with a milling end effector was used. That was combined with a bespoke vacuum bed that you can see on the left there, fitted to a 2-axis positioner. And this could hold full-size blocks, which were 1,000 by 500 by 220 millimeters on edge, and could also hold the shorter blocks. Now we determined to use a single 125 by 40 millimeter high volume cutter because we didn't have access to a tool auto changer. We wanted it to be quick and efficient process. So to enable this, we adjusted the block geometry, which you can see on the right here, so that the face was used for high volume cutting, and then the edge was used for putting in slots, which gave performance relating to rainwater drainage and air pressure equalization. So you can see how the profile for the roof block evolved. Yeah. So the top were the initial by hand versions. The one in the middle is the robot milled block used for the cabin, and the one at the bottom is a slightly more elaborate geometry that we ended up using for the house after we learned some lessons along the way. And yeah, so here's after a lot of work, mostly by Matthew and Mike Arnott, this is a robot cutting a roof block. So yeah, so when that was working well, that would take around 15 minutes or 20 minutes per block to cut. And there was quite a bit of work on robot calibration and adjusting the cutter speeds before we started getting blocks of sufficient tolerance. And again, that was work that Mike Arnott was heavily involved in with Matthew. They really bore the brunt of that work. Yeah. It wasn't quite as simple as we'd initially hoped it would be, but it did work very well in the end after quite a long time. So here you can see some wall corner blocks, a block on the left on the cutting vacuum bed, and on the right assembled. And here you can see the first section of wall that we assembled at the Bartlett, and that was an exciting moment because it was at that point that we realized that we could actually proceed with this method and it might actually work. So anyway, something we discovered, and particularly Matthew discovered, that was that it wasn't such a clean process as we'd initially assumed. So we thought, cork, robotic milling, it'll all be beautifully accurate and clean, but it wasn't quite like that. For some blocks, around 20% of their volume was cut away during milling, and this gave an awful lot of cork dust and granules. And we were interested in life cycle and environmental sustainability on the project, so we gathered the granules together and we gave them to project partner Team Hour, and they experimented with finding out what they could make with these granules. And things they made included, on the left you can see a cork lined terrazzo that they cast the floor with, and on the right you can see cork fuel briquettes that we in the end used by the house block fabricator to heat their factory over winter. So moving on to contribution to the broader research. So we've looked at the kind of use of robotics. What did that do for us more broadly? So we used the robotic milling method to shape all of the blocks for the cabin prototype. And you can see here that they were assembled at UCL to make sure they fitted together properly before being taken apart and then transported to site for reassembly. So you can see the cabin being assembled here. Relatively simple assembly by hand on site with no glue or mortar used. So there's timber with a CLT floor platform, cork walls and roof, and roof light on top that brings light in and helps to weigh the structure down and stop it blowing away. It's relatively clean and simple to build, and a full-size cork block weighs around 13 kilograms, so fairly easy to handle. Here's the cork cabin in its initial form. We used it to test as a test building, and we learned a few lessons and modified the system as a result of that testing. And this, along with a range of in-depth lab tests, enabled us to develop and de-risk the system to the point where it was ready to use, and Matthew and Dido were happy to use it in the cork house. So for the cork house, all 1,268 cork blocks were fabricated by Wapdoodle on their 5-axis milling machine, which you can see here. Now, it was using a method informed by the robotic milling method. So robotic milling is great for basically quite low cost capacity in research projects, but the 5-axis mill is much better when you want to turn out over 1,000 blocks. It's much faster and more effortless. And yeah, so here's David Stilito putting together some of the cork blocks. There we go. So here's a photograph of the completed cork house on a nice sunny day. And this is what it looks like inside. It's got quite an atmospheric balance of light and shadow. And it has...
There you go. Okay.
Are you okay, is it?
Yeah, hang on, we're just a bit behind you. Yeah.
Okay. Has a nice toasty aroma and quite a soft acoustic that makes it really good for living in. And this is, we haven't really addressed this in depth, but here's the life cycle of cork house, which was quite a big focus of the project. You can see the materials taken from biodiverse forestry, waste from forestry, made into blocks. Robotic milling enables a simple dry jointed system to be assembled on site. And then at end of life, it's easy to disassemble for reuse, or because it's 100% plant-based, it can just be returned back into the biosphere. So the use of robotic milling lowered the barriers to enabling us to proceed with keeping the system simple and dry jointed, where we wouldn't really have been able to use those geometries if we had to sort of hand carve them. So it demonstrates the kind of robotics as an enabler to sort of broader ambitions in relation to forestry and architecture. And here's just the final slide that just acknowledges some of the partners that worked on the project. So that's it. Thanks very much.
Thank you very much, Matthew and Oliver. Muchas gracias. Después continuaremos con la ronda de preguntas, así que podemos continuar con Tom. Tom, are you ready to present?
Yep. Can you hear me all right?
Yes, I hear you properly.
Perfect. So let me just share my screen. You see that okay?
Yes.
Yeah. So yeah, I mean, first of all, thanks for the invitation, Marielle and Mike. Long time no see. I'm Tom. I'm a researcher at the Center for IT and Architecture at the Royal Danish Academy in Copenhagen, which is where I got my PhD. Before that, I was also teaching and working at the Bartlett for a stint. And today, I was Marielle and Mike asked me to talk about the work I've done at CETA in my PhD, which is quite a lot of material to cover in 10 minutes. So I'll try to give a snapshot or overview of what it was about, as well as some some current research that we're doing, continuing on from some of that stuff. So first of all, what is CETA? CETA is the Center for IT and Architecture. As Mariella mentioned before, it is in Denmark, in Copenhagen. And the kind of central aim of CETA is to explore this intersection between digital technology and architecture, or the impact of the digital culture on technology and architecture. And we do that through lots of participation in conferences, publications, an active community of research across the EU and abroad, lots of collaborations in EU projects and other research networks across the world, and through making, through fabricating full-scale demonstrators and research prototypes and exhibiting them in different places. So to begin with, my PhD was part of a larger research network called InnoChain, and this is a EU Horizon 2020 research network that ran between about 2015 and 2019. And the main focus of InnoChain was to look at this idea of the linear digital chain from design through to manufacturing and assembly, and how this could be disrupted. So how to introduce iteration or kind of a recursiveness, or disrupt that linear flow and develop new ways of thinking about materials and the way we build things. So that was a consortium of 6 different academic institutions across the EU and the UK, the Bartlett, CETA, ITK in Stuttgart, IOA in Vienna, KTH in Stockholm, and IAC in Barcelona, and a variety of industrial partners. So among them, big architecture firms, fabricators, engineers, software developers, and so on and so forth. My particular project was based on timber, or on the topic of timber, and I was partnered with Blumer Lehmann, which is a Swiss timber contractor, and White Architecture, who are a Swedish architectural practice. And it began with a couple observations of the timber industry. First being that the use of structural adhesives over the past 120 years or so has dramatically changed timber products and what we can do with timber. The timber industry is highly automated, highly driven by information, and very, I mean, mature in this sense. And lately there's been, or the timber industry generally has a strong propensity for prefabrication. And yeah, and we're only seeing more and more of that today, along with kind of new notions of digital craftsmanship, or craftsmanship in a digital age with digital information tools, and as we saw, robots and CNC machines. So the focus of my PhD was the glulam blank as a point of focus to explore the material performance of wood, and how to zoom in on maybe some of the more demanding applications of wood and technology, and the glulam blank, which is this kind of raw material between sawn lumber and the finished component, was kind of was the focus of that of the project. And this was looking at the manufacturing or design to manufacturing process, as well as the manufacturing process of glulam elements, and speculating a little bit how we can explore the design potential of this area in between sawn lumber and the finished component. On the one side being an additive process of glue lamination, and on the other hand being a subtractive process of machining. So how to expand that space of design into earlier processes, such as lamination and what happens in manufacturing, and also bring that knowledge forward into the design process to make that more accessible to architects. So between CETA, White, and Blumer Lehmann, it developed into the kind of 3-part project that was about how do we model these processes and materials. So how do we start to encode these in the tools we use to draw and create models and information? How do we materialize these objects? So what are the processes and new takes we can integrate into the actual materialization of glulams and complex timber forms? And then finally, how is all of this implemented into design practice, or how can it be leveraged in a multidisciplinary architectural practice setting? And within that, there was a variety of sub-projects and experiments, just a few of which I'll just gloss over here. But when it comes to modeling, the PhD developed a series of software tools, workflows, and methods for encoding a lot of the material behavior and material properties of, or glulam specific properties into digital models. So in this sense, it was trying to add a sense of glulam materiality early in the design process to give architects something very early on to kind of give an indication of downstream complexity and difficulties. Along with that, there's the question of, well, what happens at the material level? How can we encode properties such as fiber direction and different wood properties at an element level and at a material level? And then how does that kind of propagate through the design and more meso and macro scale considerations? And then on the materializing side of things, it was very much about, well, now that we have the potential for these very unique and bespoke forms that are tailored towards particular design objectives or performances, how do we actually deal with them on a material level? And this led to a series of experiments where with Bloom & Lehman, we integrated a series of scanning methods into their factory and into their process to look at how we can introduce, in the spirit of Industry 4.0, how do we start to merge the space of the model with the physical production. Yeah. And then as a way of developing a design practice, it was these tools and methods then were tested in a design context. So how can we actually start to use these for design, for competition projects, for development projects at White, for example. So on the left is a entry for the Tallinn Architecture Biennale in 2017, which was about testing the tools to as a way to manage complexity. So given a highly complex structure with several hundreds of pieces, how can the complexity of information be managed from the level of the overall design down to all the details, and how can we develop a feedback link between what are the constraints and limitations at the element level, the bending limits of the wood, the material requirements of each glulam blank, the machining constraints, as we saw from robot limits and all these kind of things, and how can we relate that to the larger model. It's an idea called multi-scale modeling, where you address several different scales at the same time, or in a kind of ecology of models. And then on the right is a bridge project that was developed with White as part of one of their developments, which was about building the case for timber. In the beginning, this was proposed to be a simple concrete footpath bridge. And part of the work with White was to build a strong case for actually changing that into a timber bridge, and to convince the client, the stakeholders, and the rest of the project teams at White that this is a good idea. So part of that was also then looking at how can knowledge gained in fabrication and in manufacturing, for example, from Bloom & Lehman, how can we integrate that into tools and very early in the design process to look at optimizations that we could, or decisions that we make very early on to make it all possible. So it was successful in the sense that it became a timber bridge, but it hasn't been built yet. So it's, but part of that also was an optimization of geometry, and just through control of how the glulam blanks were made, there were reductions in kind of projected costs of things. So that was interesting. And then the final demonstration of the PhD project was kind of taking the process from end to end. So from the digital design of a kind of variant of the bridge project to a small component of it, taking it through to production and an exhibition, integrating the sensing methods that we worked on at Bloom & Lehman, integrating it with generation of fabrication data, alignment on the machine, and final execution. So that's what that resulted in. And what the PhD develops is this notion of a material practice, or a digitally augmented material practice around freeform timber. So what are all these? So on the one hand, you have all the digital software workflows. On the other hand, you have the physical manufacturing constraints and considerations there, and necessary knowledge, and how can we merge that into a design practice that engages deeply with these issues. And it kind of proposes a this digital timber continuum, which is a play on Branko Kolarevich's notion of the digital continuum, which is between design and machine. And now if we add in that element of material properties and material behaviors, then it becomes kind of specific to digital timber. And then just to briefly talk about some ongoing research. So the PhD looked at the value chain between lamination and the manufacturing and assembly of glulam elements. And then the question was, well, what if we extend that, the focus of, or what if we extend this integration further back in the value chain, back to sawmilling and forestry? So this was looking at developments in forestry and sawmilling and information technology. So for example, on the left, we have Tree Metrics in Ireland, who are doing developing this idea of the Internet of Trees, where they, with landowners and forest owners, they 3D scan forests. I mean, much like they've done at Hook Park as well. And they build up this library of what is growing where, what needs to be harvested. And this is all sort of packaged up into interface and made usable to the owners. And on the right is a company called Microtech, which specializes in the CT scanning of timber logs at sawmills as a way to maximize the value yield of logs and kind of optimize the material exploitation from harvesting. And these were interesting to us as because they exist, they're largely, but they're kind of untapped in design. So there's all this information on the other side of the value chain, which we believe with some design integration and some new workflows, we can actually start to leverage in design. So this RawLam project came of that. It was how can we deploy these new technologies into developing kind of hyper-specified laminated elements. And this is what the data looks like. These logs are harvested and brought to the sawmill. These are what the CT scans look like. So they're these kind of insights into the material before, without actually removing any material. So there's this high resolution of data of the interior structure of material, which becomes very interesting for us as designers, because if we know what's in there, then we can start to think about how do we want to allocate this material, or where do we want to put it. And this first prototype explored this. So given some basic performance demands like the quality of wood around a joint, the outer flanges of a beam, the amount of curvature in a certain glulam element, we could start to allocate notions of material quality against notions of performance demands. And by mapping the data from the log, or mapping precise parts of the log onto precise parts of the element, we can achieve a kind of more thorough exploitation of the material. So it's not just about extracting more high value product, it's about using lower quality product where it can be used more precisely. And in this way, trying to kind of, nudge the needle a little bit in how we exploit timber in industry. But it also leads to very beautiful representations of these kind of, intersecting digital geometry with the digital log, and what that reveals about the interior of the log, and how we can start to map that onto our digital modeling tools. Becomes very interesting. So on the left is just some, playing around with model, kind of extracting, as you can see, extracting little fragments and seeing all the knots, seeing all the data that's inside. But of course, the challenge is in how do you track the wood from the forest all the way through to the construction site, bearing in mind that there's different timescales involved, there's different technologies, there's different stakeholders, and it becomes a very sort of elaborate network of actors. But this is kind of where it's at. We're still developing this with Microtech and with Tree Metrics and with some other partners. We're building up partnerships in Sweden with the forestry industry there, who also have a very urgent need for new ways of thinking about how they are exploring forests. So I think it's not only a Danish or a Swedish concern. I think it's a concern across the world about how we use our forests, and we need better ways to do that. So that's it for me for now. Oh yeah, just one kind of sub-project of the ROLM project was DeepSight, which was building up a computational framework for working with volumetric data. So now that we have models that aren't only about describing surfaces of objects, but actually describe the interior media of objects, we also need to change the way we think about stuff. So these are, this is also tapping into some other research projects at CETA, which look at other biomaterials, such as bio-based 3D printing and grown materials, such as mycelium and mycelium composites. So this is a framework that, that asks, how do we actually understand material just beyond the surface? If we are broadly shifting towards a more bio-based economy of construction, we need new tools and new conceptions of how do we model and represent and utilize these very complex material assemblies. So I'll leave you off with that. Thank you very much again for inviting me, and thanks.
Thank you, Tom. Thank you very much. Very, very interesting.
Great.
Well, I think we have enough time for the round of questions. Tenemos suficiente tiempo para la ronda de preguntas. No sé si alguien quiere partir o alguien tiene alguna pregunta que quiera hacer. No veo ninguna mano levantada aún. Frane. Frane?
Yes. Thank you for your presentations. Very interesting, all of them. I would like to ask a few questions, but I'll start just with one. Where do you see that we should focus, since we don't have carpenters as they have them in Germany or in Switzerland, and we don't have that technical level education that is required in order to improve our timber construction. And on the other hand, we see these technological tools that can enable and broaden our designs or inform our designs to have a better understanding of timber. So is it more, will carpenters still be necessary? Do you see them as part of a trade that is going to slowly fade and disappear because we have more information at hand when we are designing and more automation when we are building? Are the carpenters that need to shift and become more experienced in CNC or whatever technological tools we have, or is it architects and engineers that will take that role? How do you see the future in this scenario? To whoever wants to answer.
Sure. Maybe I'll start off, maybe just to break the ice. Just from my experience at working with somebody like Bloomer Lehman, there is still I think the carpenter will never go away. The tools are changing and the kind of interfaces that they're using are changing, definitely. But I think that having somebody with it's very difficult to replace this kind of tacit experience or deep knowledge of working directly with material, with just machines or information, because it's one thing to have a lot of information, but another thing to know when and where to use it. So this is kind of as one of my industry supervisors told me, you could have the best model with all the most kind of detailed settings, but if you don't know which settings to kind of push where, then it's fundamentally useless. So I don't think carpenters will go away anytime soon.
Yeah, absolutely. I mean, these are just tools that carpenters can use, really. Those carpentry skills aren't really displaced by this at all. But maybe the skill set shifts slightly. You still need manual dexterity somewhere along the way, but maybe the digital tools can do some of that. But absolutely those skills are necessary. And I think the interesting thing for Chile is that you've probably got a pretty huge, quite a big forestry resource, no, for large country, low population. So
Yeah.
almost start with Chile to say what's the potential, and where do you want to go, and then figure out a route map to get there. That's you've got an amazing resource there, and obviously the typical sort of plantations in Europe are very monocultural in terms of the tree species, which isn't great for biodiversity, but also we work with quite a narrow range of species that tend to be softwood. And I know there's increased interest now in the more sustainable farming of certain kinds of hardwoods too, which Chile might be well placed to contribute to, and which could result in the production of very high value timbers that could help to support more biodiverse forestry. So I'd almost say, the cork forest, the cork landscapes are lovely because they're an example of a traditional, relatively biodiverse landscape where trees play a role to give resources, but they also play a role in the hydrology and stop desertification. So I'd almost think, and I know, one of my students this year was looking at Brazilian Amazon. He's Brazilian, and also just actually indigenous practices there, and the way that those forests were farmed in a very gentle way before, where most people wouldn't have recognized it as farming, but they now understand it as actually having been farmed by moving plant, So I think that there's a lot of discussion around what kind of forestry we want at the moment, and what the potential is. And I would have thought Chile is in a fantastic position to develop a position and to sort of take a lead on certain aspects of that. And you've got a kind of resource that, say, we in England would be really jealous of. There's huge potential. So it's not so difficult maybe to acquire certain carpentry skills. If you've got a grand plan, you could do amazing things, and those skills are all kind of accessible, really, I think.
In Denmark basically doesn't have any trees, which also makes it kind of a bad place to be doing projects about timber. But I think the expertise these days as well is quite easy to move around in many ways. But I think it would, from my point of view, it would start with developing the need for more timber construction, for example, and this is often done through the education of or like the promotion of timber in construction, for example, and convincing clients or convincing stakeholders that it is a good idea to build a timber. It is possible to have very high quality buildings, as there are tons of examples of, and that it is possible in Chile. And maybe that's a side as well to point out in the conversation.
Convincing congressmen.
Yeah, but also to what Oliver was saying, it was relatively recently that somebody pointed out I think it's a UK website, or it's called Lesser Known Timber Species, where they document basically everything that's not standard, so nothing spruce, pine, fir, or beech, or oaks, but everything else of the thousands of timber species that there are, and they show really interesting projects that are done with timber species that I've never heard of, many of which are South American or kind of from non-North American or European sources. So I think that's a really interesting effort to keep an eye on as well. And I think there's a lot of untapped potential here, because at least in Europe, the softwood forests are being stressed. Right now, I don't know what it's like in Chile, but in North America and in Europe right now, there's a shortage of lumber. Lumber prices have like tripled in the past 6 months, and I think they keep going up. So we're kind of seeing the kind of downside of the increased popularity of timber as well. Whereas it's great to say everybody should build out of timber, but once everybody does, then you start to run into different kinds of problems. So I think tapping into this whole other world of all these other species that are underutilized and can be sourced sustainably and developed has great potential.
Excuse me, but we have a similar example with the wine in Chile. For many years we didn't care about wine, and suddenly someone looked, some French, I think, looked and said, "What, you have Carmenere here? This is a species, it's already dead in Europe and maybe in the whole world. And you still have it originally, you know?" Yeah, we have it. You know what? And then started everything with the wine in Chile, you know, and maybe we will have something like that with our species and our forestry.
Yeah,
Okay.
that's a really good
I shut
analogy.
up.
Yeah. Because, I mean, really, Chilean wine's fantastic, isn't it? And it really tends to beat European wine on the whole now, and it's really recognized in Europe. So that's a really nice analogy. I mean, just think of the natural resources you have there and what you could do with them. And it was interesting to see that you always felt like you started off from a position that was behind, maybe Germany or something. But in terms of the resources, it's fantastic. Yeah. And I agree with Tom. Maybe part of the exercise is in positioning timber as something that for people to aspire to. And certainly in Europe, there's been a real swing across to a lot of the prestigious projects are in timber now, whereas 20 years ago they would have been in steel and concrete. But I think there is an issue too that there's always timber's become very fashionable in Europe, but then there's still a lot of looking to do at the kind of forestry we have and the extent to which that is sustainable in relation to biodiversity, and also there's sometimes a blind acceptance that it's positive in relation to carbon emissions, but it's not always a good thing to cut a tree down because half of the mass is below ground and that rots. And so, forestry practices can reduce the carbon storage capacity of land. And a lot of that sort of stuff isn't factored in the mainstream discussions actually in Europe at the moment. So in some ways, I think there's a peak blind acceptance that timber's positive. And as Tom said, you actually can't just build everything out of timber. You'll get shortages. There'll be all sorts of issues. It could displace food growing. So I think that really indicates a drive towards more of a differentiated high quality timber industry as probably something that will be more sustainable in the long term, which is kind of fascinating really, because it gets very interesting rather than a very generic kind of mass timber. And Tom, some of your research was kind of pointing at that in use of differentiated timber, I thought, and but we're really at the outset of that, and I think Chile's maybe in a great position to play a role in that. Yeah.
I think the issue of is there enough wood is always very interesting, because I've found that there's very often two very different, completely opposite viewpoints. One is if you talk to the manufacturers, they say, in 1 minute we grow enough wood mass in all of Switzerland to make a skyscraper. In 1 minute, that's how much tree mass grows. On the other hand, you say there's other people saying that, well, there's just simply not enough biomass on the earth to support the amount of the scale of transformation that people are aspiring to, for example. And another interesting study, which for me was surprising, was that this kind of nuanced thing, like is cutting down trees is bad, but because it's removing them and but at the same time there's it's kind of yes, but because cutting down the trees stores the carbon into buildings for a longer period of time. Otherwise, a tree dies in the forest and rots. So there was this article I found that that talked about this, which for me was a surprise. It's saying that it's not either leave the trees grow or cut them all down, which is the answer. It's kind of this combination of the two. I mean, like Oliver, you were saying about responsible harvesting, knowing when to take it out, when to store it, or when to leave it, is crucial.
Yeah, absolutely. Yeah. No, I mean, and timber's definitely going to stay a really positive part of construction, as it has been since we started building. I mean, it'd be fascinating to hear more from Chilean colleagues, because I mean, I really don't know much about the situation in Chile, but I'd love to find out a bit more. And I think the wine analogy is great. And I remember from being in Chile too. I mean, it's not such a good analogy, but your seafood is amazing too. It's obviously slightly different, but but the seafood is
you
just
remember
really
wine,
kind of
especially?
world-class. I remember the wine and the seafood. I just want to come back and just drink wine and eat seafood. It's just fantastic because it has such a unique geography with a huge Atlantic, with a huge Pacific
yeah.
coast and the topography with the mountain. Yeah. So it's an amazing place to start. I mean, I think, you know, starting with a kind of strategic review of the kind of current forestry conditions and setting aims for where you'd want to get to in relation to things in Chile and maybe export markets as well it's a pretty exciting thing to be a part of. Because timber's definitely, you know, people are really excited about timber at the moment in a way that they didn't used to be.
Yeah, I mean, that's why we are here in a way. That's why we are talking. I mean, this table is part of 5 tables more that we are discussing different topics. And one of those is forestry. What about the resource? How many trees we have? If it's possible to just dream in a city built by wood and not by concrete. We are in different, like discussing different stage of the problem in a way. But particularly, like, we want that. We want to just jump that gap that we have with other countries, even if we have a lot of forests and we have the potential to be that the construction can be like made by wood and high percentage, I will say. Franny will just be more precise on that. But in terms of like the technology, I have a question for Tom, especially because the table's about the technology, how the technology can help us to reach that aim or that, like, how to say meta, like that dream in a way. What is the role of the technology specifically? So how about, for example, the collaboration between the industry and your research? How important was that? Because we have that gap here in Chile, like the things that doesn't communicate too much each other. We have some of the biggest technologies in the big companies and the forestry companies. They have the CT scan, they have a lot of technology, they have robots, they have everything. We have some in the academia, as we see with the Francisco's work. We don't have much in the small companies, and we don't have in designers or the makers. So how this connection with the people who just invest the money to build is important, or was important for you in the development of the software that you did and the technology that you are developing?
In my project, it was extremely important. The PhD was built on these 2 partnerships with architects on one side and a contractor fabricator on the other side. I spent 6 months with each. So 6 months in the factory with them, looking over their shoulder and just asking questions. And I think you mentioned it. I think the communication aspect is the most important. Just opening lines of communication and trying to find a common ground of interest and how. I mean, from the academic side, you have the chance to be very provocative and very speculative and kind of poke them in the side and say, hey, what about this? They're, as business in my experience with my partners, they've been very business oriented. They have a business to run. The things they find interesting are not often this 50-year in the future speculative stuff that maybe is interesting for a particular type of research. For us, especially with Bloomer Lehman, it was very much feeling each other out and finding a common way we could help each other, or where our interests could be combined. And I think it was very much a negotiation of okay, so let's look at their process. Let's look at how does that kind of fit in with our research aims, and then how can we start to make inroads, and then kind of it was bit by bit trying to proposing some small changes, some small experiments, and trying to build upon that. But I think the key factor there was just opening the lines of communication, saying we're not going to come and try to completely change the way you're doing things. We want to understand what the process is, where we can start to maybe give a few nudges and start to have an impact. I think any big company, any production, I think not only in timber, it's a massive ship to steer. So changing directions takes a lot of time. And academic projects, they tend to, they can be focused on very different things very quickly and propose very dramatic shifts. So I think that kind of middle ground, or search for middle ground, is key.
Yeah, I found something very interesting about also Oliver work and Matt's work, that is just how much change of impact a medium company or firm can do with research involved. that can you just create a product that is like amazing and a use for that product that is amazing, and how visible that can be as example for everyone or other small business or companies or architect designer that can just follow the same steps. I found that really, really interesting, and I don't see that much happening of that in Chile, a part of the thing that's happening in the university itself. I don't know what you, ¿qué opina Francisco respecto a eso? ¿Cómo nosotros llegamos como academia a afectar a quienes están produciendo, a quienes construyen casas, a quienes diseñan conexiones, a quienes básicamente transfieren ese conocimiento a lo que nosotros vemos en la urbe, en las casas, en cómo se están construyendo las cosas? ¿Qué acercamiento han tenido ustedes como universidad o como laboratorio a eso? Al traspaso de esa información al... No sé si me entendiste mi compleja.
Sí, lo voy a intentar graficar de una manera bien anecdótica, que en verdad ha sido bien harto de prueba y error, ¿no es cierto? Cuando compramos por primera vez una fresa para mecanizar madera, lo primero que hicimos fue buscar las tablas, ¿no es cierto?, las tablas del fabricante, en que nos especifican las velocidades de avance, ¿no es cierto?, la velocidad de rotación del electrocillo con el que se debe mecanizar. Y probamos con esa información y nada, no, fue imposible. Luego, muchos años después, lo que pasó con el trabajo que hicimos con el aserradero Oipir, también nos pasó algo muy similar. Nosotros ya teníamos un conocimiento específico de encontrar esas velocidades, que es una serie de variables que afectan, pero que logramos encontrar una que nos funcionó, y esa que no funcionó la usamos siempre. Pero cuando llegamos al aserradero, yo llevaba una herramienta, el aserradero estaba poniendo el material, en este caso una madera laminada de pino oregón, que él tenía otro conocimiento con otra herramienta. Al mezclar, tuvimos que interpolar las cosas, porque ni las variables que yo conocía, ni las que Miguel González del aserradero conocía, ninguna funcionó para la herramienta, para la combinación herramienta-material. Entonces, yo creo que ahí volviendo un poco al tema de lo que decía Tom, de que el carpintero nunca, o siempre va a faltar, de hecho, porque no teníamos a quién preguntar, no sabíamos quién tiene esa información, a quién le preguntamos. El fabricante de las fresas no tiene idea de cómo se utilizan esas fresas en un robot. El fabricante del electrocillo tampoco, el fabricante del robot menos. Entonces, ¿cómo creamos nosotros ese conocimiento desde la academia para llenar esa brecha de conocimiento, ¿no es cierto?, en la combinación de la tecnología que estamos utilizando con los materiales locales? Es una anécdota bien simpática, pero que permite un poco graficar, ¿no es cierto?, esta brecha, ¿no es cierto?
Sí, es lo que decía Franes, de alguna forma. Sí. O sea, ¿en qué momento cambiamos o nivelamos, hacia dónde crecemos? En el fondo, cómo se van permeando el conocimiento de abajo hacia arriba, porque hay muchas cosas que nosotros, probablemente la gente que trabaja en tecnología no tiene la menor idea. Y cómo hacemos esa mezcla, permear eso. Hay otra pregunta que tengo que es interesante acerca del uso de nuevos materiales que le quería hacer a Oliver también, que la voy a hacer en español, que tiene que ver cómo el proceso de llevar un material que no es considerado un material, o un material certificado, por decirlo así, a ser un material que va a obra. Creo que eso es súper interesante en Chile, porque no estamos hablando solamente de madera estandarizada, sino que estamos hablando de madera de todos los subproductos del bosque que pudiéramos utilizar y llevar a materiales de construcción. Can I ask you, Oliver, a question about, I just made it in Spanish, so can I explain the context first, about how was the experience to bring a non-standard material, or a material that probably was not used? I don't know exactly how we work in UK, the thing of the certification of the material, so they can approve that material for being able to use in construction. We have in Chile like a big gap that our standardization of material is quite difficult to reach. So the gap for introducing or researching new materials and components, etc., is quite difficult to reach. What is this? How was the experience?
Yeah, I can explain that too. Yeah, absolutely. I mean, or Matthew, I don't know, Matthew, if you want to come in, or Matthew's had quite a big day.
I don't know.
So but let me know if you want to, otherwise I'll just carry on.
Quite late in the UK, so
yeah.
I imagine. Maybe he left.
Yeah, I'll carry on for now. But
yeah.
So I mean,
I know he's saying that.
Is he saying? Okay, a couple of things, yeah. So, yeah, I mean, they're both really good points. I mean, you were quite perceptive in picking up that point about combining a research and a live project, and it's very hard to do that. And that was really purely down to Matthew plus Dido, because Matthew applied for the research funding as an industry partner, and then he also stepped forward with Dido to actually fund the house project. So that enabled us to do something which is incredibly rare, which really leveraged both things and gave much bigger impact. It's very hard to do that because normally research funding would never fund an actual live project in that way. And normally a live project would be too risk averse to take a fresh out of the research lab system and build with it. But Matthew and Dido made the decision to take that risk on, and that enabled us to go right from initial idea through to a project. And in relation to, I mean, the material is been used in construction for 100 years. It's normally used as it's the original foam insulation material. Before the petrochemical foams were invented, this was used as a foam insulation board. But you're right that it was used for a lot of very unconventional things on the project. So it's never used as the primary structure in a project normally, and it was there. It's never used to keep the rain out of a building, and it's never used to deliver air tightness in a building. And there are requirements in the UK on that. So what we had to do there was a lot of lab testing, and we also needed a really good engineer who was on the research side. So Andrew Lawrence, Gavin Maloney, who we work with in Arup, are part of their kind of research team basically, who get involved in more unusual projects. And it was critical, their input, along with Professor Pete Walker from University of Bath, who's an expert on material characterization. Their input was critical in taking the kind of architect's crazy idea and actually saying, yeah, it's actually okay to proceed with this. And it got UK building regulations approval based on the engineers effectively verifying the design and submitting sort of 75-page reports in relation to structure and fire and that sort of thing. And that there is UK regulations in some ways are quite permissive. So there is a route whereby you can do that in the UK. And at the same time, that doesn't mean that we haven't got a system that's fully certified or anything like that. Yeah. So, and in order to take it to that point, you'd probably need another, $500,000 or $1 million to actually undertake all the certifications to get to the point where it was an established, standardized system that anyone could use, or potentially a lot more than that, actually. Yeah. So we found a route through to building a building it's a proper building. It got certified, but that was only with exceptional engineers.
Yeah, we're in the same position.
Yeah.
Tengo una pregunta que es para Tom, para Oliver, también para Francisco y quizás Luis Felipe, que es parte también del equipo de Francisco. Si pudieras nombrar o encasillar las claves de qué es lo que se le tiene que enseñar, ya sean pregrado o posgrado, en este caso estamos viendo ingenieros o arquitectos, ¿cuáles son los key, las cosas que deberían saber antes de salir ahora de la universidad o antes de sus posgrados, para lograr tener ciertas nociones de esto, en el fondo, de fabricación? O sea, estamos hablando de que queremos incorporar el uso de tecnología para potenciar el uso de cómo usamos nuestros bosques y que la tecnología sea una especie de palanca, pero ¿cómo logramos eso? ¿Cuál es el mínimo? I'm going to translate the question to Tom and Oliver. Basically, if you can describe or identify like 2 or 3 key points or technologies or knowledge in general that students, architectural or engineers need to have before they finish the undergraduate, related with automatization and technology, which one do you think are the more important? It is programming, it is related with, that's related with robotics, it's about like modeling and 3D representation. What do you think is the key? Why I'm asking this question? Because we have not much of that in our schools. It's not that we don't, but we have how many architecture faculties in Chile? Like 50 around, Frane? Slow. Our very long country. So it's about to just think about it in your in your point of view, which is the key
Yeah, I'll
technology?
have a go at that. Shall I, Oliver?
Okay, everyone can ask. I want everyone to just say it.
Yeah, sure. Sorry, yeah, I'll have a go at something. Yeah, I don't think it's any. Actually, I don't think it's any one particular aspect really. I think actually the important thing from both the projects tonight that tell me is that it's actually the overview of all the parts of the Tom called it the value chain, and we called it the building life cycle. So I think it's for students, it'd be the relationship between the landscape resource system, manufacturing processes, fabrication processes, building processes, and then the end of a product's life or the end of a building's life. So it's for me, it's about really understanding all those stages and the relationships between them, because that's what helps you build a grand plan, as Oliver called it. In relation to that question about the carpenter, the carpenter, that's only really significant in relation to how the carpenter understands their role within that overall building life cycle or material life cycle, right from the resource through to the end of its technical life.
Yeah. Who else? Thank you very much.
I agree.
Felipe?
Please. After you.
Thank you. I just say I agree with Matthew on that. I think at a very elementary level, recognizing that the material you buy at the building supply store didn't just appear there, and it has a provenance and it has a background to it. But there are also maybe two more slightly technical things that I would suggest is one is on if we talk about modeling, knowing what it is actually that you're modeling. Is it just trying to reproduce stuff we see, or kind of ways that we draw stuff, or just for representation, or do we actually use modeling as a way to actually instruct further processes, right? So the difference between a rendering and an information model, right? That difference, which can come from programming and also just from drawing specific geometry for a toolpath or whatever. And the other thing is kind of understanding what is actually automation in manufacturing. What does that actually mean? And for me in my workshop kind of life, that began understanding when a tool moves and cuts, right? And then you have an automated tool that does a similar thing. Like what is that difference? What is automation actually introducing that is different from handheld tools, right? And that can be it can be a very small thing, just a hand router versus a CNC router, right? But just kind of making that leap between, I'm now telling the machine to do what I did with my hands over here. And now I know that, okay, so this is what's actually happening when I tell the machine to run these complex tool paths or and so on and so forth. I think those would be the two kind of technical aspects, I'd say, is look beyond modeling as reproducing forms, look at the structure of information, I think. And then that leap between, like the carpenter working manually and the carpenter's sensibilities still exist when he or she uses a automated tool. Yeah. It's just a different context.
Yeah, thanks, Tom. Luis, Felipe?
Well, I think the key is structured thinking. I spent many years after I studied architecture in Chile. I spent a little more than 6 years studying and working at the Bauhaus in Germany. And as I came back to Chile and tried to educate architects into the computer science and computer programming and so on, I always saw and had very clear that the key, if you're looking for one key and the keyest thing, I could say, and I still think it is just structured thinking, pensamiento estructurado, because I think my whole life, and I read it from another guy, of course, but I totally agree with that the nature of architects is to be integrators. You know, it's natural born integrators, different from engineers and any other kind of profession. And the way we integrate things can be any way, but when you try to take this way, you know, the route, the manners of computing and automation and so on, you just need to think structurally. And is one of the things normally in most of our country, I would say in the whole of our country, and maybe in many schools of architecture all over the world, the mainstream way of teaching architecture is still the same, you know, holistic and not necessarily structured. Although I may say perhaps Anglo-Saxon way of thinking and way of educating architects is a little more structured as our southern way of looking space, you know, architectural space. But even though structured thinking is the key for me, at least.
Thank you, Luis Felipe. No sé si alguien más quiere apostar. Estamos llegando al final de la reunión. ¿Alguien más tiene una pregunta, creo? ¿Pablo? ¿Pablo? ¿Sí?
Yes, well, my English is not very good, but I can to express my idea. You know, this question is for Oliver, because I want to know if you have any experience with using the bark of pine. You know, Chile has a lot of pine planting, but what is your experience with pine bark?
Yeah, that's a really interesting question. I mean, so we did all this research on using cork and actually making things, and then in relation to that, both Matthew and I got quite interested in the history of using timber and bark, cork and bark. And because I'm a full-time academic, I had a bit more time than he did to research it, so I looked into it a bit more. And I mean, actually, you know, cork's interesting because it's a bark that's had a continuous use for thousands of years by people in construction and other things, but bark has been used in construction and on pretty much every continent, and it used to, you know, historically it was used much more extensively, and there's very little use of bark now compared to when you look back historically. So pine, you know, some of these coniferous trees were used extensively by indigenous people in North Europe and also in North America to make, obviously, you know, long houses and all sorts of forms of architecture are clad in various types of bark, and obviously birch bark canoes and all sorts of amazing constructions. But those traditions have really fallen by the wayside. So you do get bark, they call them bark sidings, used in the States sometimes just as a form of cladding instead of timber. I haven't come across pine being used. There's a particular species I don't recall the name at the moment. So I think it's interesting. I mean, obviously cork's different because it's the outer bark of the tree. It's dead material. You can remove it quite easily without harming the tree. Whereas most barks we'd think to use would be harvested at the point when the tree's cut down and stripped. But I think there's a huge potential for the use of those barks in construction that as far as I know, there's just no focus on that at all at the moment, really. Yeah. So it's interesting. I don't have any good current precedents, but I think there's a massive potential. I mean, historically, bark was used widely in indigenous architectures. In Japan, it was interesting because it was elevated to a very high form of architecture in the cypress bark roofs, the traditional roofs you get on temples there, which actually were seen as the highest form of architecture historically, and where the use was only permitted in temples and by a very narrow number of aristocratic families for a period. So, but most of the history of the use of bark is a kind of low architecture. but it's an amazing material that has got the potential to, for all sorts of uses. So
Thank you, Oliver.
Okay, thank you. Thank you.
Frane, some comment? ¿Algún comentario o cerramos? ¿Estamos bien? Yep.
Vamos nomás. Sí.
Okay. Quiero dar particularmente las gracias a todos los invitados. Francisco, muchas gracias también a Luis Felipe, que yo sé que está convaleciente y puede estar acá con nosotros. Gracias también por la labor que hacen, es importante. And thank you very much to Tom and Oliver and Matt also that talk at the end. Thank you very much for that. And thank you for coming to just show us a little bit of different reality for us. And it's very inspiring for us. Thank you very much. And gracias a los asistentes también de la mesa. Les recuerdo que por favor rellenemos el Jamboard. And also to the invited, if you want to just share any of your vision that you couldn't share now and you think is important for us as a knowledge to transmit to us, just you're invited to just fill the Jamboard link that is there in the chat. Muchas gracias, nos vemos la próxima sesión. Gracias a todos, muchas gracias. Nos vamos.
Thank you very much.
Thank you
Thank
very
you
much.
for.
Hi.
Thank you. Thank you.
Thanks. Very nice to pop in.
Amazing
Welcome to Chile.
presentation.
Yeah, we'd love